Okay, we finally have reached the end of roots. However, the one idea that we have left is something unique. We've been seeing lots of stuff that has been kind of repetitive, but we're going to work with the properties of these roots, and this is going to be a little different. So we saw in the last video that we could make roots into fractional exponents. So like 2 to the 1/2 was the same as the square root of 2. So these are the same thing. And we also saw that 2 to the 5/2 would be the same as the square root of 2. You could do this either way. Square root of 2 to the 5th, or you were allowed to do it on the inside too. It didn't make any difference. Okay, now, but when we work with them as fractional exponents, all the properties of exponents then hold true. So I already showed you this one. If I had x to the second times x to the third, we add those and it becomes x to the fifth. Well, that's what we're going to do here on a. So I have a to the 1/2 times 2, or 2 to the 1/2 times 2 to the 5/2. We add those. Now when you add fractions, you got a common denominator. You can add the numerator. You get 6 over 2, which reduces down to 3. And 2 to the third is 8. You see where this is going? Getting a little confusing. So x to the 2/3 times x to the 4/3, that means addition. That's really addition. So when we multiply exponents, we would be adding these. So we have a common denominator. They add together to get 6/3, which would just be x over 2. Now do I have c done? Yeah. So we are multiplying these. So we're adding those fractions. We're adding those exponents. And we get down to z to the second. Okay, so try these, or you can watch me. So I'm adding 2/3 plus 4/3. So this is 3 to the 6/3, or 3 to the second, which is 9. Now here we are adding these when you multiply. So I've got y to the 9/3, which is y to the third. Got one more here. We're adding these. So I've got m to the 4/4, which is just m to the first. Okay, same thing here. I've got 5 to the 3/5 plus 7/5. So I've got 5 to the 10/5, which is 5 to the second, which is 25. Okay, now I'm adding these. So I'm not going to show it all again. If I'm adding these, I'd have 8/8, which is just z. If I'm adding these, I'd have 7/7, which is just n. Okay. Yeah, okay, so I wonder where they were going with this. Yeah, we've seen another way to do this, but this would work. I guess that's the point they're doing. So if you had a power to a power, you multiply. This is x to the sixth. Well, that's what they're asking us to do here. We're going to multiply. So if I multiply 4 times 1/2, that's 4 over 2, or 2. So this is all going to simplify down to x to the second. Now we could have done this with the root approach. Like if we take the square root of this, we'd get to the same place. But they're showing us a nice clever trick here. So I've got a power to a power, so that's going to be y to the 6/3, which is the same as y to the second. And z to the 9th is going to be z to the, so I'm taking a power to a power, so that's going to be 9 times 2/3, which is going to be z to the 18, z to the 18 over 3, which is z to the 6th. Okay, we'll try some more of these. A power to a power would multiply, so I'd get p to the 10 over 5, which is p to the second. I'd get q to the, so power to a power, that's going to be 24 over 4. So this is what I'm doing if you struggle with your fractions. So you can think of that as 8 over 1, multiply across the top, multiply across the bottom. So I've got q to the 6. Okay, over here I've got x to the 24 over 3, which is x to the 8th. All right, some more of these. You you could do that. Well, I'm just going to keep doing it. Do you see if you did this, we would be multiplying 6 times 5/3. You could reduce that if you wanted, if you remember all your rules of fractions, and you're going to get 10 over 1 or just 10. Yeah, I think that's what they're intending here. So if we're going to multiply these, we've got 12 times 3/4. You could reduce that, and you're going to be left with s to the 9th. Here you're going to be left with m to the 2nd. You see the 9's would cancel. So we're multiplying these. The 9's would cancel. You'd get m to the 2nd. All right, things are getting real crazy now. We saw if we had x to the 5th over x to the 3rd, we slashed them down, but what you're really just doing is subtraction. 5 minus 3. Well, that's x to the 2nd. Well, we're doing the same here. Let's see how they did showing it. Yeah. So this first one, x to the 4/3 minus 1/3. Well, that would be x to the 3/3, which is just x. Same thing here on b. We can subtract those fractions, and we'd have y to the, well, they jumped ahead a little bit. That'd be 2/4, which reduces down to 1/2. And now you could have, well, I guess they just want, you could have made that square root of y, but I guess they're working with exponents, so they left it there. Okay, the last one, we would subtract that. 2/3 minus 5/3. Okay, well, that's negative 3/3, which is a negative 1. So I have z to the negative 1, which means we can move it down to the bottom, which is how they got that. Okay, try your hand at some of these. So I am subtracting. I would get u to the 4/4. Well, that's just u. Now I can subtract these. I'd get v to the 1/5. So you have a common denominator, you can just subtract. This would be x to the negative 3/3, which is x to the negative 1, which could be moved down below. Okay, so I'm just subtracting again. They have a common denominator, so it's not too hard. I would move it down below. I'm on C here. Okay. Okay, so same thing. We are getting more complicated, but we're taking the power to a power. But what's going to happen here is the 2/3 essentially gets distributed into each of them. So let me show you. So it's going to be 27. He's getting a 2/3 power. And the u to the 1/2, he's also getting the 2/3 power. So we just have a little bit of extra work in front of us. We saw in the last section how to simplify this. We would take the cube root and then square it. And we just saw how to do this, which is a power to a power. We would multiply. So let me show you. So they distributed that 2/3, which is what I showed you. Now taking the cube root of 27 would get us 3, and then we square it. That's where they're getting 9. Now a power to a power, so we've got u to the 1/2 times 2/3. Well, I could reduce that down to u to the 1/3. So we saw this as individual parts. The only new idea is that you're distributing this exponent to both of them, and it turns it into essentially two separate problems. So I'm like giving the 2/3 to the 8, like here, and I'm giving this. So the 2/3 is going to each of them. Now I know how to do this. I'm going to take the cube root of 8 first, which is 2, and then I'm going to square it. Gets me 4. And a power to a power, I'm going to multiply. that reduces down to 1/6. Okay, try these, or watch me if you want to. I'm going to give that exponent to both of them. Okay, I'm going to take the fifth root of 32, which is 2. Got to make sure, yeah, 2, and then to the third. So the fifth root made 2. Now I'm taking that to the third power, and I get 8. Over here with the x, I have a power to a power. That means multiply. Those would cancel. I'd get x to the 1/5. Okay, I'm going to give 1/3 to both of these. Okay, I'm going to take the cube root of 64, which is 4, right? Yeah. Okay, now a power to a power means multiply. This will be y to the 2/9. So I'm doing 2/3 times 1/3. Hold on, let me just see what we got going here. How many of these we got? Okay, I think there's only one more idea after this, so let's try a couple more of these. So I'm giving the 3/2 to both of them. Okay, square root of 16 is 4. 4 to the third makes 64. Now this is a power to a power, so I'm going to multiply them. The 3's reduce. I get m to the 1/2. Okay. I'm going to give that root to both of these guys. Okay, this means square root 81, which is 9. And then 9 to the third, what is that? I looked that up, I don't know. I had that in a recent video. 729. That makes 729. Now, we've got a power to a power, so I'm going to multiply them, which would mean I could reduce the 2's. So I'm doing 2/5 times 3/2. There we go. Okay, this is the same thing. I'm not sure what it's really accomplishing other than it just being all variables. I think this is easier. I'm giving the 1/3 to each of those. So m to the 3, so that's, I guess, why. M to the third to the 1/3. So if I multiply 3 times 1/3, that's just going to be 1. So I make an m. N to the 9th to the 1/3, if I multiplied those, I'd be multiplying 9 times 1/3. So that's what I'm doing here. Multiply them. Reduces down to 3. That's where they got that. Oops. Well, I've written all over this one, so hold on. Let's just do it ourselves. So I've got p to the 4th. He gets a 1/4 power. And I've got q to the 8th, and he gets a 1/4 power. So if I multiplied these, I'd get a p. If I multiply these, I'd get q to the 2nd. Oh boy. Okay, so all kinds of madness going on here. So the first thing I'd want to do is, well, we could do this a couple ways. Did they move everything up to the top? I don't know if I do all of them like this, but I'm going to move everything up to the top. Let me show you what I mean. Do you see what I've done? I moved this one up to the top by making him a positive. Now, if I'm multiplying, remember what we did if we had x to the 2nd times x to the 3rd, we just added. Well, there's 3 of them now, but let's just add all of those. Now, it's plus -1/4, so I'm going to subtract that guy. I'm just adding up all the exponents. Well, I would get 2, I'd get 8/4, which is just 2. So believe it or not, all of that turns into x to the 2nd. Now, I don't know if this is the approach I would take on all of them. I'd have to see what else they throw at me. But I'm going to move this up top and do that again. I'm going to make all of them up to the top. And the way I can do that is make that 2/3. Swing them up to the top. Okay, now they're all at the top, but we need can we see that this is y to the first? I'm going to make it 3 to the third. 3 over 3, I should say. Isn't that still y to the first? Now, I can add these. So I'm adding up these exponents. So that's 4, 5, 6, 7, 8, 9. So I've really got y to the 9 thirds, which is just y to the third. Okay. Yeah, so I'd recommend you trying these. It looks like my trick is all you would need on all of these. I don't think they've thrown anything else at us. Pause it if you want to try it, but I'm going to do them now. I'm going to move everything to the top, which now I'm moving this to the top, it becomes 5 thirds. Okay, now I can add these. So they have a common denominator, so I've got 5. I'm going to get 6 thirds, or m to the second. Okay, let's look at b here. I'm going to move everything to the top. Okay, that's 6 over 6. Okay, so I made the end of the first 6 over 6 so that I have a common denominator. Now let's add this. I've got n to the 18 over 6 is n to the third. Okay, I don't expect any variations with this, but I'd really recommend you try it. Pause the video, but I'm going to go ahead and get started on it. When I move that up, it becomes a positive. Common denominator, all I got to do now is add them up. I got 17, got u to the 15 over 5, which is u to the third. I'm going to do it again one more time. I'm going to go ahead and make that 2 over 2 because I know where this is going. Move that up, it becomes a positive. So I've got 7, 8, 9, 10. I got v to the 10 over 2, which is v to the fifth. Okay, now this section is much harder than what we've been doing, at least lots of crazy rules. But the key is you just need to understand it follows all of the regular rules that we have when we work with exponents. They're just fractions, but all the rules apply. So don't let, if you are confused and not sure where to go, just say, okay, what would happen if I was doing this with x to the second to the third power or whatever? All of those rules apply, and that'll get you through.